All right, hopefully you were pretty successful with solving linear systems by graphing. Now we're going to look at 7.2, which is solving linear systems by substitution. This is doing the same thing but without graphing, so that you wouldn't always have to graph your problem. So here's the first example. Example number 1. Again, they've given you two equations. X plus 2y equals negative 6 is the second equation. X minus y equals 3 and x plus 2y equals negative 6. I could graph these to see where they intersect. If I didn't want to graph them, or if they were yucky ones to graph, then there's other options, and this is the second option to solve. So I'm going to give you a step-by-step basis. So step 1, here's my step 1 of what to do. On either equation, get x or y totally by itself, and it doesn't matter which equation you use. So I'm going to give you the instructions. Get x or y by itself in one equation. Okay, in one equation. It doesn't matter which one. So I'm going to take this one, I'm going to take this equation, the first one, and I'm going to get x by itself. So here's the equation, x minus y equals 3, and I'm going to get x by itself. That's my choice. Okay, there's a lot of options here. You could have chosen to get y by itself in this equation, or you could have chosen from this equation to get x by itself. Choose the variable that has a leading coefficient of 1. This would not be a good idea to try to get this y by itself, because you will end up with fractions. So I end up here with x equals either 3 plus y, let's write it that way, 3 plus y, or y plus 3. Let's do it y plus 3, it doesn't really matter. Okay, so I've gotten x by itself. Now what this says is that x equals all this junk. What step 2 is you take all this junk and plug in this information in for x, because x equals this. So wherever I see an x in another equation, I can substitute in this information. So here's step 2. Let's write it down in words, and then I will show you mathematically. We are going to substitute the expression is the part that doesn't include the equal sign, from step 1. We are going to substitute the expression from step 1 into the other equation and solve for the other variable. So solve for the variable you have. We're reducing it, going from, instead of having two variables, having one variable. So I'm going to take this expression right here, or at least the y plus 3 part, and I'm going to substitute that y plus 3 in for x. So I'm going to take this other equation that I haven't messed with, and this part, x equals all this. So wherever I see an x, I'm going to substitute it in. So instead of x here, I'm now going to put y plus 3. That is what x equals. Okay, I'm going to put that y plus 3 here, and then I have plus 2y equals negative 6. Do you see how we only have y's now? So we could solve for y. So these parentheses are not needed. Okay, I just wanted you to see what it was that I added in. I have like terms, so 1y plus 2y is 3y. Oops, plus 3 equals negative 6. Subtract 3 from both sides. Divide by 3, and I have that y equals negative 3. So I have solved for one variable. Step 3 is the easiest part. Okay. Step 3 is the easiest part, is I'm going to substitute my y value in, back up here and here to solve for x. So since I know what y is, I can quickly find what x is. So let's write that in words. I'm going to say substitute the value from step 2. Oops, let me move that up. Substitute the value from step 2 into the expression, or let's do equation, because this is the equation in step 1. So I had this equation in step 1. I know that y equals negative 3, so I'm going to plug in negative 3 for y, and I get that x equals 0. This is the whole thing. I'm looking for the point where these two lines meet. The point in which these lines meet, my x is 0 and my y is negative 3. This is the point where these two lines meet. And you could verify that, you could check that by taking that point and going back to your original problems and plugging in and making sure it is indeed a solution for both of those equations. Okay? I'm going to give you one more at this point. If you feel you guys are okay, you can pause this, or you can continue and watch another example. I want to give you a second example of one that's maybe not as easy. So I have 3x plus y equals negative 7. I'm going to move a little faster. And then negative 2x plus 4y equals 0. The only one I would want to get by itself in this case is this y right here. This is the only one that has a leading coefficient of 1. That's the one I'm going to want to work with. So I'm going to write step 1. I'm going to try to get this y by itself. So I do that by subtracting 3x. And there's what y equals. Step 2 is I take the second equation and wherever I see a y, because that's what I know, y equals all that stuff, all this I put into here. So I'm going to have negative 2x plus 4 times, that's 4 times y, whatever y is, all of that negative 3x minus 7. I need to distribute that 4. I now only have x's, so I could solve for x here. I have negative 2x minus 12x is negative 14x, minus 28 equals 0, add 28 to both sides, and I divide by negative 14, and I get that x equals negative 2. Right there, that is part of my point, that x is negative 2. Step 3 is using that expression that I had created from the step 1, is I know that x is negative 2, I plug my negative 2 in there. So I have y equals 6 minus 7, so y equals negative 1. So I have negative 2, negative 1. That is my point. That is the solution to this system, and you can check by plugging both of them back in and verifying. So now I'd like to ask you to just go ahead and try number 1. Just do number 1 together yourself on the back side of your worksheet, and then if you have remaining time, please start your homework. Have a wonderful day, and I'll see you guys shortly. You can also send me Edmodo requests if you have some questions.